We're going to look at factor by grouping. In this first part, whenever we're factoring by grouping, this has already actually been grouped for you. We're looking at the greatest common factor to kind of set it up here for us. In the greatest common factor, in this, I'm going to call it number 1, if you look at this binomial, this is one term and this is the second term. What they both have in common is that they both have the binomial x plus 5. So as before, when we take out a greatest common factor, what's common here is x plus 5. And then we always multiply that times what was left after we took out the greatest common factor. Well, if I take out this x plus 5 of each of these terms, I think you can see what's left is x plus 3. And this here would be my answer. You can easily check that by multiplying your two binomials and foiling that out, distributing that out, and you're going to come up with, if you distribute out your question, you'll come out with the same polynomial. In number 2, it can be with a plus or a minus. But what I have here, number 2, we'll call this number 2, again I have a common factor. And the common factor in this term is b minus 3. So I'm going to factor out that b plus 3, b plus 3. When I factor that out times, I'm going to write what's left. And here again you can see here's the a, but in this case it is minus 2. And so that's going to be that second binomial. So once I take out what's common, and the b plus 3 is common, I take that out, that leaves me a plus 2. To grow just a little bit, in this case I look at both of these binomials right here. They're the exact same except they're in the opposite signs. In this binomial I have a positive n and a negative 3. Over here I have a positive 3 and a negative n. Well, they're not quite common. So what we have to do, and we'll call this problem number 3, is we have to make them the same. So I'm going to keep this first binomial, m times n minus 3, but what I'm going to do is I'm going to factor out of this a negative 1. When you factor that negative 1 out, it's actually going to change this sign right here. So this becomes plus 2 times, and this becomes n minus 3. This is easy to check. If I go back up to make sure that they're equivalent, negative 2 times 3 is negative 6. Even down here, 2 times negative 3 is still negative 6. Distributing negative 2 times negative n, I have a positive 2n. Here in this second step, 2 times n is still a positive 2n. So I've just changed the way the expression looks, not the value of the expression. Now look at this and say, you know what, I see that common factor. That common factor is the binomial n minus 3. When I factor that out, what I have left is m plus 2. So if I were to FOIL out this answer here and distribute in the original problem, I would get the same polynomial. Easy way to check. Number 4, this is one that you have to work from scratch. This is called factor by grouping. That's what you want to do. You want to choose two terms and group them together where they have something in common. So if I look here, I'm going to say these first two terms, they have 2 and x in common. The last two have a 3 in common. So I'm going to group the first two terms, 2x squared plus 4x, and I always say plus, plus, plus in the middle. Then I'm going to group the last two terms, 3x plus 6. I'm going to factor out what each have in common. I chose them to be together because they had something in common. In the first binomial, they have 2x in common, so I'm going to factor out the 2x. When I do that, when I factor out 2x, that leaves x, plus, factor out 2x, that leaves 2, plus. Here, what they both have in common is 3. I factor out the 3. Taking out 3 leaves x, plus, taking out the 3 here leaves 2. Then again I see, you know what, I've got the same common factor of a binomial, x plus 2. Times, in my final answer, I write what's left. If I take out the x plus 2, I have 2x left in the first term, plus 3 left in the second. If you were to FOIL this out, combine all your like terms in the beginning, you would get the same, in this case, the same trinomial or the same polynomial. That would be my answer. In number 5, we're going to throw in a couple of negatives. You can group the positives together and the negatives together if they have something in common. But for visual sake, I would always recommend grouping a positive and then a negative, a positive and then a negative together if they have something in common. Sometimes you can't help it, but if you can, it will look and see, you will be able to see more clearly the like terms. So here I'm going to group positive x cubed and negative 3x squared because they have a whole bunch of x's together. And then plus, plus, plus. I'm going to group the last two terms together, my positive, then the negative, the positive, then the negative, and they both have 4 in common. So I group these because they have x squared in common. I have x to the 3, the 2. Those are my only two options. I choose 2. Taking out 2 x's, that leaves x minus 3. This way I can keep that plus right there in case I need it to stay, stay consistent. In this binomial, I have 4 in common, so I'm going to take out a 4. Wrote my parentheses too soon. Take out the 4, and that's going to leave x minus, and 4 will go into 12 3 times. Again, I see that common factor right here of the binomial x minus 3, and that's going to leave me the binomial x plus 4, x squared plus 4, x squared plus 4. And this is my final answer. Both binomials multiplied together, that's my final answer. So I had to choose what they had in common, choose 2 terms that had something in common, group them together, and then take it out. On this last one, I'm going to pick 2 things that they have something in common. And I want to choose a positive and then a negative. So I'm looking kind of carefully here, and I'm saying, 15x and 35 both have 5. 3x squared and 7x both have x. So we could group those together. And you can group your negatives together. It's not that it won't work. You just have to remember to factor out the negative, So here I'm going to group 15x positive and negative 35 plus. Then I'm going to put my positive 3x squared and then my negative 7x. I'm going to group those together. So when I group these right here, I have 5 in common, so I'm going to take out that common factor of 5. 3 will go into 15, 5 will go into 15 3 times, minus 5 will go into 35 7. Plus, what I have common in the second binomial is an x. Taking that out, I'm going to have 3x minus, and then x will go into this. Taking out that x, that would just leave 7. Again, I can see the binomials that I have in common, 3x minus 7 times 5 plus x. That would be my answer. I do want to do one more, and it's this one. Hopefully time will permit. Again, I'm looking at these. I'm going to group these together. I'm going to group a positive with a negative. So I'm looking right here. I have 3x cubed. My negatives are 2x squared and negative 6x. I think I'm going to choose these 2 right here. So I'm going to group 3x cubed minus 6x plus plus plus. Then I'm going to put my positive 4 first and my negative 2x squared second. I want to kind of make it look the same, the positive and the negative, the positive and the negative. And this first one, what I have in common is 3x. I'm going to take that out. That's going to leave x squared minus 2. When I factor out that 3x from each of these terms. Plus, what I have in common here is just simply a 2. So 2 will go into 4 twice, minus x squared. And I look and say, I'm looking at my 2 binomials. They're exactly the same, except they're the wrong signs. So remember that when they're the same binomial, different signs, I'm going to factor out that negative 1 from my second parenthesis. So this first one will stay the same. Then the plus becomes a minus when I factor out the negative 1. And what that does is it changes the negative x squared to a positive and the positive 2 to a negative. Now I can take out that common factor of x squared minus 2 times, leaving 3x minus 2 as my second binomial. Easy to check, just multiply it through, and you should get the polynomial that you started with. This is factor by grouping.